Welcome to a new video of my home automation OpenHAB and Node-RED series. In this video I'm featuring this box, which is my first assumed to be completed Blynk project. And this is a project I was talking about in my previous Blynk introduction video. So I'm planning this as a sort of like Swiss Army IoT device of the garage, which is supposed to do a couple of things. There are a few relays inside, so I'm planning to control the garage door and the gate door using this. And also it has like two plugs for any auxiliary power, let's say maybe a lamp that can be remotely turned on when you are trying to get into the garage. And the other one is I'm planning that to be used as a charging a socket for a charger extension. And the reason that I'm using as a charger extension, because I will have a piece of program which would turn this output on, and then after, let's say, 6 hours, when the charging of the device is like a cordless drill or some hedge trimmer or something like that is assumed to be completed, then it automatically turns itself off, saving the standby power of all the, you know, the chargers for these various garden and shop devices. So let's see what makes this stick. In case I forgot to mention, I'm doing this project for my brother, who managed to lock himself out from the house by leaving the key inside and didn't have the garage remote with him either. So and going back to the Blynk 101 video, you probably remember this screen where I said that, you know, what are the different reasons I would use Blynk instead of something else, let's say Node-RED or any other homebrew application. The first one is if I want a simple and easy way to implement a user interface. So that's definitely a case, because they mostly be used on a mobile phone, so it's like a simple app. You just launch the app and then you can control your device straight away. And then we needed easy access via mobile phone, so that's again true. I mean, mostly you would use this when you are outside home, so you are coming home and then you want to, you know, open the garage and the gate, so you can just drive straight in. The third one, which is probably the most important one in this case, so it's like a simple one-off project for him. He's not into home automation, he's not into programming, so you know, creating a Node-RED server with a Raspberry Pi, even though it's really cheap, it would have been an overkill. So for that reason, Blynk is really good, because it's providing all this, you know, cloud support and the server and the messaging and the communication. Next one, yeah, Arduino C++ knowledge, I do have that, but we will see later on that it's not really required, to be very, very honest. And lastly, yes, I'm creating this project for a third party, so right at the end of the video we will see how the sharing of the application works and how easy it is for you to create something and then give it to somebody else to use it. As I do it for all of my videos, you will find the link to the source code and any supporting documentation in the video description. Let's look at what how does it look in the inside. So I used the standard electrical junction box, which was just the right size for this project, and I have the mains coming in here from the right, so it goes into this terminal block. And then the mains power, first it goes to this small power supply, then obviously it goes into the relay and then gets fed into the two output sockets. Obviously the earth goes through, and this block here, I will use it to get the temperature and the humidity sensor well, to go to the outside of the box, and also these two relays will be used for the garage door and the gate door. So obviously they would have two separate leads leaving the box via this connector as well. Other than that, the inside is actually fairly simple. So I have the VMOS D1 Mini, and I have a power supply which gives me 5 volts, 0.6 amps, so it's just like one single block. And other than that, I have a prototyping board which doesn't have anything else, just wires and some pin headers, so I can easily connect the relay and both the Dht22 temperature and humidity sensor. The only other component besides wires and the connectors is a 10K pull-up resistor, which you need between the 5 volts and the data line of the Dht22. And as I said, other than that, it's the ready-made relay board and a cable and some, you know, DuPont cables. I had a couple of reservations about this project. The first one, or the first two concerns were about the power supply. First of all, I wasn't sure if 0.6 amps is going to be enough, because I know that the ESP is, it tends to be quite picky when it comes to the power supply, as it draws quite a bit of an energy when it actually communicates over Wi-Fi. And I mean, I don't remember the exact things, but I know people had issues with the ESP if they were not using a proper power supply. And also I have a couple of relays here, so they each draw, I don't know, like 20 milliamps when the relay is on. So altogether they could be eating about, like, I don't know, probably with the status LEDs, maybe 100 milliamps. So I just wanted to make sure that it gives it enough, it supplies enough current, but it seems to be doing that because it's, you know, it's running and I have no issues with the connectivity. So it appears to be staying on the network all the time. The other thing is I wasn't sure what kind of, so it says in the symbol that it's 5V DC, but it has this symbol which says it's probably not filtered correctly. So again, I wasn't sure if that would be an issue for the ESP, but it doesn't seem to be. So yeah, it's working fine. And having all these electronics enclosed, I thought that maybe there wouldn't be enough ventilation and the whole thing would just heat up, and that's the reason the temperature sensor is in here in the box at the moment. So I was running this setup for a couple of hours, and the ambient temperature hasn't really risen inside the box. So yeah, nothing is generating you know, a huge amount of load, or sorry, heat, which the whole thing wouldn't be dissipated as it is now. So yeah, it's working fine. Now that you have seen how the finished project looks like, let's just go through the main components first, or at least where I got them. So actually I bought everything on eBay, and most of it is from this seller, which is the Chips Dash Fans. So he has the VMOS D1 Mini board, which is, well, probably some clone board, and then you can straight away buy 1 or 2 pieces. So that's about, you know, 2.8 pounds per piece, and that it comes with the board itself, and it comes with some pin headers. So well, I'm not using these long pin headers, but I use the 2 shorter pin headers. So you can find VMOS D1 Minis from many different sellers, and also in AliExpress if you prefer AliExpress. The next one is the power supply. So I'm using this Blynk power supply one, and then you can see the output is 5V DC 3 watts, so that's about 600 milliamps. I think in some it says 600 milliamps, the others it says 3 watts. So that's it. Just make sure that you get this 5V model, because there is a 3.3 volt model as well. But the reason I picked the 5V one, because that's probably better for the relays, and you can see the different ones. So I think 01 is the 5V, 03 is the 3.3 volt, and 12 is the 12V one. And by the way, I haven't really shown this, but it comes in a nice, you know, potted basically resin box, and then you have the leads that are spaced apart are the DC leads, and the ones that are closer together on the right are the AC leads. And I just have the AC leads hanging off the PCB board, so it just gives enough clearance, and there is just more room for me on the PCB. And the 2 DC leads on the left, they happen to be the exact you know, 0.1 inch pitch, so they span across the breadboard quite easily. So it's very easy to work with. Next one is the relay. Again, it is available from many different sellers. You can see, you know, tons of these on eBay. I bought one which is the opto-coupled, which has the opto-coupler. I don't think it's really important, but they are pretty much the same price anyway. This particular seller has 1, 2, 4 or 8 channel version, so I just got the 4 channel version. It's slightly less than £2. And finally, the Dht22 sensor. It comes from Alice 1101 1983, Yeah, I managed to say it at least. These actually I bought after I finished the project. So in the project you see a DHT11, which looks almost the same as this one. It has a blue case. They has the same leads. And when we go through the software, I would just mention what you would need to change in the code to make it work for DHT11 or 22. So this is actually this is US price. So that's $2.72 per piece. And of course you need some DuPont cables and pin headers and terminal blocks for the mains and the plugs, and an enclosure. But probably you can buy one in your local electronics or local electrical supplier shop, whatever which is most convenient or sold the cheapest in your area. Before we start going through the code, let's just look at the schematics of this project. So the heart of the project obviously is the Wemos D1 Mini or a Wemos D1 Mini clone. Next you need a relay board. I'm using the 4 relay board, so I have one for the garage door, the gate, this charging station, and then let's say one more. So you can just use 2 if you only need the garage door and the gate door opening. And next I have a temperature and humidity sensor, just because the the ESP can handle, and it's not going to increase your project costs much. This particular image is a DHT11, which usually comes in a blue enclosure, and then you have seen that the Dht22 is a slightly bigger one, and it's usually white. But again, the same 4 lead package or a 4 pin package, and it works exactly the same. And finally, we need the power supply. So I'm using this High-Link all-in-one potted 5-volt 3-watt power supply. And of course, for the 2 plugs, you need some mains plugs, and depending on your application, you might want something which can fit on a project box. And yeah, you need a project box as well, which is not shown here, but that's not part of the schematics anyway. Let's go over to the wiring. So the first one, let's look at the supply wires. So the plus 5 volts, which comes out of the power supply, needs to go to the leftmost pin of the DHT11, and then the 5-volt pin, which is on the right hand side of the Wemos, and then there is a VCC pin on the relay itself. Next is the ground, and of course it goes to the same 3 devices. So it's the rightmost pin on the DHT11 or 22, the ground pin on the Wemos, which is just above the 5 volts, and you also have a ground pin on the relay board. Next, let's wire the DHT11. So I'm using the 4 pin, which is just above the ground, for the signal wire, and the signal pin on the DHT11 or 22 is the 2nd pin from the left. And you don't forget, you need a 1K resistor between the signal and VCC or the 5 volts, otherwise it's not going to work. Moving on to the relay connections, we have the pin 1, which is D2. So the pin 1 or relay 1 connects to D2 on the Wemos, and the relay 2 connects to D1. And I have to stop there because these 2 pins are really important. As I find out, whenever the ESP boots up, some of the pins of the ESP might go to low during the boot up sequence, which would be very unfortunate in this particular application, because then you have a power outage, the power comes back on, the ESP boots up, and it sends a very short signal out, and then which would energize the relay for a really short period of time, and that might enable your garage door or your gate to go up or just open. So we definitely don't want that. But this doesn't apply to all the pins of the ESP, and I have found that the D1 and D2 is one where during power up it's definitely not changing any state, so it is safe to connect them to the relay, and these relays you won't hear a click when the ESP boots up. Actually, it is the case for, I think, the next relay, the relay 3, which is connected to D3, but again that is connected to like a charger or lamp, so that would blink for a split second. It's not going to cause any issues. So remember, for these let's say 2 critical applications, which is the garage and the gate, use D1 and D2 always. And the last relay pin is relay 4, which connects to D7 on the other side of the ESP. And as you can see, we still have quite a few pins available, so I could have done a project with 8 relays and we could still control them from a single VMOS D1 Mini. Next, let's look at the mains line. So you have the neutral line, which goes into the AC side of the power supply, and it also goes into your plugs, both of the plugs, and the live wire again goes into the power supply, and then it connects to the middle pins, or the middle terminals for relay 3 and 4, and the lower terminals, which is the normally open terminals, they connect to each of the sockets respectively. And then finally you have again the middle and the lower pin, lower terminal of relay 1, which goes to the garage, and the same for relay 2, which goes to the gate to operate the gate and the garage door. I'm not sure if you remember this from the first video, so let me just highlight it again. So if you come to blynk.cc and then on the getting started page you scroll down, you find this section which is the Open Blynk Sketch Code Builder, and this is what I use to build pretty much the entire code for this project. So you select your board, which is the ESP8266. Oh, actually there is a VMOS D1 Mini. You select the connection, which is only Wi-Fi in this case. I tried SSL as well, but it didn't work for me. And you copy the authorization token. Again, you remember you create a new project, you go into the project settings, you set up you create the device within the project, and that's when you get your authentication token. And the next one is you select a project or an example. So there is already a Dht11 example. So I think I used mostly this one, and there was a few other things that I used here. I think it's there is something on how to enable or how to synchronize a virtual pin, virtual pin read write. But that's basically it. I mean, for most of the application you will find some examples here, which is quite nice. So you just copy the code and then try to mix and match, and then to come up with the final design that you need. So looking at my actual example, as you can see, while I replaced some of this header stuff, and before we go into that, I'm going to put this example onto GitHub, and you will find the link to a GitHub in the video description. Going back to the code, the one thing you have to remember, or the minimum amount of things that you need to change, even if you are going to build the exact same replica of this project, is you put your authentication token here, again what you get from the app, and you put your Wi-Fi SSID and the Wi-Fi password in here. So that's pretty much it. If you interested on how the code works, then let me just quickly go through it. I have some global variables. Here I'm setting the initial state of the charge. So by default you are not charging when the charge relay, which is relay 3, is off. And I have a charge time which is 60 times 6, so that would be 6 hours, so that needs to be set in minutes. And here I have the declaration for the different pins. So the DHT pin is pin 2, and again, I'm not sure if I mentioned this, but D1 Mini, if you search for VMOS D1 Mini pinout and you go to images, and you have these pins. You see it's like D7, but sorry, D4, but in Arduino you are not referring to the pins by these D names, but you need to use the Arduino pins, which are the these what is it, this bluish greenish color. I don't quite remember the name in English, but anyway, you need to use this. So for example, for D4, if you remember, D4 is the one where the DHT is connected, and that's the pin number for that is number 2. So in the Arduino code you need to do 2. So that's where the DHT is connected, and the type is DHT11. So if you have DHT22, you just replace it with DHT22, and then it's going to work with that. And then I've declared all the pins for the garage, for the charge. That's charging lead and the garage and the gates. So these are 4 and 5. And the rest here is standard code from the example. So you need to initialize the DHT object, and then I've also created some timers for the sensor and the charger, and they are type a Blynk timer, and that's how Blynk recommends doing reoccurring tasks. So instead of putting into the loop, you can create timers which they trigger every, let's say, 10 seconds or every minute, and or every second, and they would do some sort of logic. The send sensor again comes from the Blynk example. So this reads the temperature and the humidity readings, and here you can see in the original comments that if you change this to read temperature true, then you will get the values in Fahrenheit instead of Celsius. If it doesn't work, you get a message in the serial saying that the read from the DHT failed, and otherwise we will write the values that we got from the DHT sensor to V5, the humidity to V5, and the temperature to V6. So these are virtual pins on the Blynk, in this Blynk project. The count charger method takes care of the charging cycle. So first it checks whether the charge state is true, so that indicates that the charger is actually running, or this charge counter is running. It decrements this internal counter which counts the remaining seconds, and then it sends the remaining time divided by 60, so it sends the remaining time in minutes into V2, so virtual value 2 or virtual pin 2, which then gets displayed on the application, so you can see how much time is remaining. And if the charge counter reaches 0, that means that the charging is completed. So we will set the digital pin to high. So remember, the relay is active low, so you always need to set the digital right to the, let's say, the opposite state. And then I update V1 and V2. So V1 is the button that shows whether the charger is on or off, and the V2 is again the value. So I just put a slash saying that okay, there is no charger at the moment. Blynk write V1, again this comes from one of the examples. So this is how you handle the changes of a virtual pin in the application. So as I said, I have the V1 pin set for the virtual 1 pin set for the charger, which is a button. So whenever that changes, so whenever somebody presses on that button in the application, this method in the ESP will get called. So I will get the current value into, let's say, this pin value. So if this pin value true, so somebody just pressed on to start the charging, I set the internal state, I set the physical output which is connected to the relay, I set the counter to the charge time times 60, so because it counts in seconds, and I also update the V2, which is the remaining time. And if it's false, so somebody clicked off, turned off the charger before it automatically expires, then it just says that okay, we are stopping the charging and we are setting the internal value to low and the physical pin to high, and again the remaining time to a dash. So it's really simple. Next one is the setup, which pretty much standard Blynk code. So we will set the serial console to 9600 baud. We will print some messages. This is mine code, so it's just a good housekeeping. We set the pin mode, so the 3 output pins that we are controlling from the code, we are setting them as outputs, and we are setting them to high, so the initial value of the relay is off. And that's the standard code for connecting to the Blynk server, standard code for starting the DHT object, and then the two timer objects. So one for the sensor, which is 2 seconds. That means that I will be reading the DHT temperature sensor every 2 seconds. But that also means that you are sending the update to the server every 2 seconds. So I think this is good for testing purposes. But let's say if your project is running and you know, in quote marks final, you can probably increase that to 10 seconds just to reduce the network traffic. And the charger one is this timer is responsible for, you know, calling this count charger, which, you know, counts down the remaining, you know, charging time, and that is executed every second because the internal counter is in seconds. So the way you define the timer, so you have the timer, the variable or the object for the timer, which you define up here, which is type Blynk timer. And you have the method is set interval. First, you need the interval in milliseconds, so that will be like 1000 for every second. And the second argument is the name of the method that needs to be called whenever the timer triggers. And the loop is actually really simple because we are doing everything in timers. The loop is nice and clean. So you have the Blynk run, which is compulsory to make sure that it is running and is communicating with the Blynk server, and you also need to kick off the timers. And that's basically it. So again, if you are building the exact same hardware, these are the 3 lines that you need to update, and then you just compile and then upload it to your ESP. Because the project is already live, I can't really show how it looks like in the output, but as you can see, you have there are quite a few messages which are going out to the serial line. So I think in a first whenever you are testing this and then debugging, it's a good idea to have it connected to your computer, and then you just use the serial monitor to see what messages are coming back, because you will see that the ESP manages to connect to the Blynk server, local IPs, and some other information. You will see it in the serial console. Let's just quickly go through the setup of the Blynk project itself. So if I go into the project, you can see that it's it only has one device, and that was my first device. This is why I called it the first and it's a VMOS D1 Mini. And of course, you can create a new device here, or when you create a new project, there is no device, so you need to set it up first. And then here you see you have the authentication token, which I mentioned before, then I just have a few buttons. So obviously I need an input switch for or like a push button for the garage and the gate opener, and it's really simple. So I have this is for the garage, and it's connected to the D1. And what I have done is this originally shows as this is 0 and then this is 1. So I swapped that around because the relay is active low, and I changed that from a switch to a push because it just needs a momentary action. And then you can have the labels set accordingly, so it shows something which is relevant. And then the same for the gate is connected to the D2. So again, now here you are quoting the actual pins, not like, you know, the Arduino pin numbers, but the actual pins, the same what you can physically see on the VMOS D1 Mini. So the gate one is the same. It's D2. I have the values swapped around for active low, and then it's a push. So simple as that. And if you press and hold on the button, like you want to remove it, once you let it go, you have the option to resize it. You see, you have these 2 dots at the side, so you can make the buttons wider. You can't make them taller, but you can make them wider. So the lamp one is very simple. It's connected to D7, and if you remember, there is nothing in the code which does that. So just by creating this button here, which is a switch type, so it's not a push type, it's a switch type, and then saying that this is a D7, you know, the Blynk library takes care of, you know, controlling in and sending the data back and forth between the applications. So there's no code required for this one. For the temperature and the humidity, I have two labeled values, and if you remember, they are getting the values from V6. So the V6 is the temperature, and here in the label you just type this one /pin./C, and /pin/ means that you just type the same value what comes through the from your device. But because I put the dot here, basically saying that I don't need all the decimal places, because the Dht11 is not precise enough to show the decimal places. And I think it even comes always as, you know, just even degrees and degrees temperature, degrees centigrade and percentage humidity. So I can just skip or cut the decimal places, and exactly the same for the humidity. So that's V5, and I just put /pin./ and percentage to show the percentage sign. And so the last two bits are for the charging one. So as I said, the button for, you know, for starting the charger, it does not control a physical pin, but it controls a virtual pin. So in the code I can decide, you know, what needs to happen when this virtual pin is getting set. So it's just V1, and it has the same values. So, you know, low is 0, high is 1, and it's a switch type. And the last one is again a display value, and it's the V2, which is showing the value of the remaining seconds, sorry, the remaining minutes. And it's simple as that. So the other thing which I also need to talk about is the last bit, which when you go into the application, you have this option to share this project. So first you need to click on shared access on and off. So this is by default is on. So you click on on. You will get the message that the money that you know, this 1000 energy points that it takes to create a shared project is not refundable. And then you generate on you click on this link, and when you click on this button generate link, you will get a second screen which shows like a QR code. So somebody who has installed Blynk, they can read that QR code, and that application is basically shared for them. And you if you don't have the phone, the other phone with you, and then there is a share button, so you can send the QR code in an email or, you know, WhatsApp or whatever. So, and it's simple as that. So the other user creates an account and then reads the QR code, and instantly he has access to the application. With one single caveat, which is really, really important. Oh, by the way, that's also a nice feature. So you can add a shortcut to your home page, so you can launch this particular project directly. One other caveat, which is really, really important. Once you're happy with your project and say, okay, it's final, and this other third party, like in my case, my brother, can use this app, you have to make sure that the project is running. Because if you stop your project, the Blynk assumes that your project is not final, it's still being modified or edited. So your third party is not going to have access to the application, and he will get a message saying that your application is locked by your administrator. So just make sure that your application is running, and now you can get out of Blynk. You can even, you know, close the application, you can close your phone, you can do whatever you want, and your third party will still have access to the application. Just make sure that you do that, otherwise it gets a little bit annoying for your friend or your relative who is planning to use the app. Fitting the project was easy. There are wall switches in the garage for the door and the gate, so I placed the box closed, a little bit out of the way. The grey wire taped on the top goes to those switches, and the white wire on the other side is mains power. You can see the Th10 sticking out on the side. Luckily, there is sufficient Wi-Fi signal at the spot for the ESP to stay online without any dropouts. And just like that, the project was finished. I hope you liked this video and learned some more about Blynk and ESP. Thanks for watching, and see you in the next video.